Hi everyone! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about a mechanics of deformable bodies. Ang ating magiging topic for today is all about bearing stress. So magsimula tayo guys sa definition kung ano ba ito tinatawag nating bearing stress. So pag sinabi nating bearing stress, tumutukoy siya sa tinatawag na contact pressure between two separate bodies. Ito ay kaiba do sa tinatawag nating compressive stress because compressive stress is an internal stress caused by compressive forces or compressive loads, while bearing stress acts on the area where the two bodies are in contact. So whenever there are two bodies that are in contact, the area between them will be subjected to a contact pressure, and that contact pressure is called a bearing stress. So, para maunawaan natin guys kung anong difference yan, let me share to you this illustration and allow me to explain to you the difference between a compressive stress and a bearing stress. Okay? So, here is an illustration on the difference between a compressive stress from that of a bearing stress. And I have here an illustration of a cylindrical post that is subjected to an axial load P. The cylindrical post is resting on a block or rectangular block. So when we are talking of a compressive stress, it is actually the stress that is happening on the internal part of the structure. And we can analyze it by passing an exploratory section through this cylindrical post. And let us imagine that we try to pass an exploratory section, a section that runs in that direction. So this section now cuts this cylindrical post into parts. And if we are going to isolate the upper part from the lower part, and we can show where is the compressive stress happening. In this part of the section where this section is cut by an exploratory section is now subjected to an internal stress, and the stress developed is called a compressive stress. Suppose that we try to pass another section somewhere below this cutting section, and try to isolate again the upper part of the exploratory section. Let us try to do it by isolating this. And you will notice that each part now are subjected to an internal load. The lower part is subjected to this internal load, as well as this part. And all of them are all subjected to what we call a compressive stress. And these are all internal stress. And the internal stress is happening in this particular part. There is the compressive stress happening here and also happening there. The magnitude of which is the ratio of the compressive load over that of the resisting area. Para ipakita naman yung tinatawag nating bearing stress, let us try to go back to this figure. And this time, ang i-isolate natin is this entire cylindrical post. We will be isolating this cylindrical post at makikita natin that there is this area where the post is originally in contact with the block. This area where the two are in contact is subjected to a contact pressure, which is called the bearing stress. Kaya dito nangyayari ngayon yung tinatawag nating bearing stress. Kaya yung bearing stress, meron siyang formula equal to P over the resisting area. While the compressive stress, gaya na binabanggit ko kanina, is happening internally on the post. So although, kung mapapansin natin, both the bearing stress and the compressive stress have the same magnitude in this case, but they do differ in the sense that a compressive stress is happening inside or internally, while a bearing stress is happening at the area with which this part is in contact with this block. So the magnitude may be the same, but their effect on the material would be different. And so if we're going to compute for the bearing stress, in this particular example, the sigma sub B is called bearing stress. Normally, the sigma is subscripted by B to differentiate it with a compressive stress or a tensile stress, so that this will be denoted with a symbol, a subscript B, to designate or to denote that this is a bearing stress. In this case, yung P is called the load acting over the area, and A sub R is the resisting area, and normally it is called the contact area between the two bodies in contact. Okay, somehow may mga instances kasi na yung ating area is a curved area. What will happen? Okay, how do we compute for the bearing stress kapag ang ating area is a curved area? Like in the case of a bolted connection. Halimbawa, sabihin natin, okay, ang formula is equal to the same as P over A sub R, na kung saan ang AR natin dito will be called as the resisting area or the contact area between two bodies. But this time, it should be computed as the projected area on a plane that is perpendicular to the direction of the force. Kumbaga, yung ating curved surface, ipinoproject natin on a plane that is perpendicular to the direction of this bearing load or this load. And that area is called the resisting area. Para ipakita natin itong scenario, let us try to imagine that we have here an illustration of a simple bolted connection where the plates are connected with a bolt. If the plates will be subjected to an axial load in this direction, the bottom plate is subjected to a force that is directed to the right, while the upper plate is subjected to a force that is directed to the left. You will expect that this rivet will be in contact with the plate on this area, yung curve na ito, di ba? And if we are to compute the bearing stress or the bearing area will be the area of this curved surface projected on a plane. So if we will be projecting it on this plane, makita natin that this area becomes our projected area, and the magnitude of that area will be equal to the diameter of this rivet multiplied by the thickness of the plate. Kaya yung ating nagiging area dito will be equal to the diameter of the rivet multiplied by the thickness of the plate. So let us have this sample problem. So in the problem, there is a lap joint that is shown in the figure. I have here the figure. That is fastened by 4 of 3/4 inch diameter rivets. So in the problem, we are to calculate the maximum allowable load F that can be applied if the maximum shearing stress. When we say maximum shearing stress, it refers to the stress at failure, which is equal to 14 KSI. And the maximum bearing stress in the plate. When we say maximum bearing stress, it is the stress at failure of the plate. And that is equivalent to 18 KSI. The factor of safety for shearing stress is 1.25, while the factor of safety for bearing stress is equal to 1.5. Assume that the applied load is uniformly distributed among the 4 rivets. So I would like to explain the use of the factor of safety here. Although we are given the magnitude of the stress at failure, we will not be using that in the computation for the magnitude of F, but rather we shall be reducing it because there is a factor of safety. Only the magnitude when factor of safety is applied shall be used in the computation of F. And accordingly, because we are given the factor of safety, then we solve for the allowable stress. How do we solve for the allowable stress? Knowing that the factor of safety is the ratio of the maximum stress or the stress at failure to that of the allowable stress. And knowing that for the shearing, we have a factor of safety of 1.25. So if this will be substituted here, we will have 1.25 equal to 14 KSI, being it the maximum stress, and divided by the allowable stress, thus giving here an allowable stress equal to 11.2. Sa makatwid, ito lamang yung ating gagamitin in the computation of the maximum permissible value of F. Now, after that, what are we going to do? So, pwede na natin makompute yung permissible load based on the allowable shearing stress. That the formula will be equal to the allowable shearing stress equal to V over A sub R. Because it is given in the problem that we will be assuming that the load will be distributed uniformly among the 4 rivets. Therefore, this V, if we are to take the allowable stress for each rivet, will be the magnitude of the shearing load would be acting on one particular rivet, and that will be equal to 1/4 of F, because F shall be divided equally among the 4 rivets, where the value of B will be equal to F over 4. Kaya pag isa-substitute natin ito, ano yung ating allowable stress? We have here 11.2. Okay, the value of B is now substituted with F over 4, and the area will be equal to the area of the circular or the rivet, which is circular in shape, and that is equal to pi d square over 4, where the diameter is equal to 3/4. So when we substitute the value here, okay, you will notice that inches will cancel, and that F can be computed to have a unit of kips. So simplifying, then the value of F will be equal to 19.79 kips. So this now is the value or the permissible value of F if we are to consider the shearing stress of the rivet, considering that there is a factor of safety of 1.25. However, if we are to consider the allowable bearing stress of the plate, okay, knowing that there is a factor of safety of 1.5, and that the ultimate or the maximum bearing stress of the plate is equal to 18 kSI. Therefore, from here, we can solve for the allowable bearing stress of the plate, which is equal to 12 kSI. Now, considering that, we will be solving for the maximum permissible load that will be based on this allowable bearing stress from the value that stress is equal to P over the A sub R, which we have just shown a while ago. This value of P will be the shear bearing load acting on each of the bearing area, the area with which the plate is in contact with the rivet. And this value of P, assuming that the load is evenly distributed among the 4 rivets, therefore here P will be equal to F over 4. And that area can be computed to be the area projected. If we will be projecting this area, okay, this area on a plane perpendicular to the direction of the F, this area would have a value equal to 3/4 multiplied by 7 over 8. Hence, substituting that value in the formula, therefore, we will have here 12 kips per square inch will be equal to F over 4, K divided by 3/4 multiplied by 7 over 8. Hence, from here, we can compute for the value of F in terms of kips, and that is equal to 31.5 kips. Knowing two possible values of F, what F are we going to give? Okay, because we wanted or we need to determine the permissible value without exceeding any of the stresses, allowable stresses. Therefore, the value that we are going to give shall be the smaller one, which shall be governed and controlled by the shearing stress on the rivet. Hence, okay, we shall have here our conclusion that the maximum permissible F is 19.79 and is controlled by the shearing stress in the rivet. So guys, that is the sample problem that I can show you so far in terms of the computation of bearing stress. At sana sa pamamagitan itong aking sample problem na pinakita sa inyo ay naintindihan ninyo ang konsepto ng bearing stress and how are they used in the computations of problem that deals with this kind of a concept. Thank you guys for watching.